welcome everybody to our colloquium for today. So thanks for joining. I know a few people are still calling in, but I wanted to take just a minute or two to introduce our speaker today. So our speaker is Olga Wilhelmi from the National Center for Atmospheric Research in Boulder, Colorado, where she is a project scientist in the Research Applications Laboratory, as well as the head of the GIS program there at NCAR. I believe that she's been at NCAR actually for, I think this year is her 20th anniversary at NCAR or close to it. Before she arrived at NCAR, Olga did her PhD at the University of Nebraska-Lincoln, as well as her master's, and actually did her bachelor's originally in geography at Moscow State University. So Olga works on a variety of topics as it kind of relates to kind of social science and climate change, particularly as it relates to kind of human environment interactions, particularly when it comes to things like climate change and how that impacts weather hazards. Using tools like GIS to help communicate and research those applications. And particular in one of the ways in which I've gotten to know Olga is through her work on kind of stakeholder engagement, usable science, and risk and resilience. And so maybe just a little background for the broader group is that Olga was part of one of the large NSF Coastlines and People proposal that was put together by many of us at Stony Brook, both in SoMAS and other departments as a co-PI. And so it's an example of somebody that I haven't met in person, despite spending much time in Boulder, but an example of how the pandemic has actually allowed us to bring people of different disciplines together to work on topics, even though we've been all virtual and sitting in Zoom world. So with that, I'll turn it over to Olga for her presentation on the societal aspects of weather extremes and climate change. So Olga, take it away.
Okay, thank you so much, Kevin, for the introduction. Can you all hear me okay?
Yep.
Yep, okay, perfect. So yes, today I'm going to give an overview of some work that we've been doing at NCAR related to societal impacts of weather, vulnerabilities, risk, and show a couple of projects that highlight the intersection between atmospheric and social sciences and also spatial sciences, as Kevin mentioned. So I'm actually going to turn off my camera just in case, if the bandwidth is a little bit shaky here. Okay, so I just wanted to start by saying that right now we all live in a world that is changing at an unprecedented rate. We have a rapidly growing population, rapidly growing urbanization. Many aspects of society are changing in terms of its demographics. And there is also a lot of pressures on different sectors, such as water, food, energy. Some of the issues related to security aspects of natural resources are becoming an important part of the development and some of the bigger societal challenges. And of course, climate change is one of those societal challenges that we need to think about and address, especially in this growing and very rapidly changing world. So when we look at some of the model projections, and unfortunately this animation is not working for some reason today, but just looking over time, there is a really kind of a major change in the average surface temperature of our planet. The human activities already have increased the average temperature of the Earth by approximately 1 degree Celsius since the 19th century. And if you're going to stay at the same rate with our emissions, this increase is going to be even higher, especially in the northern latitudes. And so what does it mean in terms of how do we experience this climate impacts, climate change? And the way people experience the changing climate is through extreme weather events. So if you look at this map, this is the graphic that was put together by NOAA that shows the billion-dollar weather and climate disasters that took place in the US just this past year in 2020. And so this has been an unprecedented year, not only with regard to the pandemic, but also this year has been the record year in terms of the billion-dollar disasters, weather disasters in the United States. And what's really concerning is that if you look at just even the last few years between 2016 and 2020, on average, we have seen approximately 16 events, 16 weather disasters that exceeded $1 billion in damages. And that's twice or more than twice the amount of the long-term record. So as you also can see on this graph, there's a variety of disasters. There's hurricanes, thunderstorms, hailstorms, wildfires, drought. And so the human capacity to deal with these disasters can be quite affected, especially when we think about this past year and all the other social and other economic pressures that we have experienced during the pandemic. So what does it mean actually to have a disaster? So disasters are a social construct. And about 20 years ago, American sociologist Dennis Mileti, he wrote this book that's called Disaster by Design. And when we look at the risk of different disasters, we sort of understand that as a combination of not only environmental processes, but also social processes. So the risk is a combination of hazards, vulnerability, and exposure, and I will get into some of those concepts in more detail. But the important thing to understand is that just being exposed to hazard is not enough. There's also vulnerability, and all of those interactions are affected by larger processes that happen with the environment, land surface characteristics and how they're being changed, urbanization, climate variability and climate change. And also on the social side, socio-demographic changes, development, governance, land use planning, and some of the other macro level stressors and pressures that we're experiencing, for example, like the effect of the pandemic on our society. So let's take a look at some of those concepts and how we can unpack them to understand what particularly may be affecting the risk, different levels of risks, and different types of adverse effects that people experience from weather and climate extremes and disasters. So one thing to mention is that risk is not a fixed concept. It is constantly evolving as a continuum, and it changes from seasons to years to decades, and especially some of those social processes that happen in terms of development, some of the socio-demographic processes, they have a really long history, and the way our society is constructed and shaped and operate, all of those kind of long-term processes can significantly affect the risk. We also want to understand that it can be different from local scale to global scale, and there's all these different environmental and processes and can affect the risk all the way from the neighborhood scale to a global scale. And as the risk and all those different factors that shape risk change over time, of course, we have decisions, we have all these different social environmental interactions that can affect how the society evolved and how the environment changes and what contributes to disaster risk. So now let's take a look at some of those concepts in a little bit more detail. So when we want to understand the hazard, in this particular case, we're interested in weather and climate hazards. So typically we're interested in some of the physical characteristics of the phenomena, intensity, duration, spatial extent. It's important to know when the event is happening, what time of day, what season, and also potentially looking at the cascading effects, because disasters or hazards sometimes happen either in sequences or they can co-occur at the same time, but in different locations, and affect the resources that may be used to mitigate and respond. We can also look at their exposure, and exposure means the presence of people, structures, or assets in the area that would be affected by a hazard. And so we can look at, there are people, homes, there are non-residential buildings, what kind of infrastructure, services, ecosystems, and just broadly, what kind of economic and cultural assets exist that can be affected by a hazard. Oops, wrong direction. So now let's take a look at vulnerability. And vulnerability is a combination of sensitivity and capacity to prepare, respond, and recover from an event. So when we look at the sensitivity, we look at some of the physical predisposition to harm. And those could be individual characteristics such as age, health, disabilities. It also could be building characteristics and building quality. How fragile the structures are they built according to a particular code that may be affected. We're also interested in infrastructure resilience and broader socioeconomic and social cultural factors that may increase susceptibility of either people or structures to the impacts of the hazardous weather events. Adaptive capacity, so in coping capacity, that's one of the aspects where I do a lot of work in my research. And that's where we trying to understand what elements of households, communities, and societies broadly can potentially either exacerbate or mitigate the risks and vulnerabilities. So here we're looking at some of the characteristics related to individual and social knowledge, attitude, practices. For example, are people aware that they live in a hazardous area? How do they perceive their risk? What kind of protective actions do they have? What sort of experiences they may have? And do they have resources to respond in an event if they need to evacuate or work on some structural mitigation for their homes? Also, it's important to look at the community resources and what types of programs may exist to help individuals, families, and community members in an event where they don't have resources to mitigate the impacts of the hazard by themselves. Social capital and social networks have been shown to be one of the strong disaster mitigating factors that could significantly reduce the impacts if the community cohesion or family network or community networks come together to help each other in the event of a disaster. One of the interesting aspects of adaptive capacity is the information capital, information capacity. Do people have access to information? What type of information they trust, and how they can use that information to make decisions? And we will get to that in a moment, because that's something that we think about quite often, because that's one of the aspects of risk management that we can inform through better forecasting, warning, and risk communication. And so here, when we look at all different, not all, but many different ways to intervene and reduce future risk, we can kind of look at some of the broader concepts of disaster or risk management that goes from preparedness, mitigation, response, recovery, and in particular, we can look at whether communities and organizations have plans. Are there any structural mitigations that's being implemented, both through urban design, through planning, and also through some of the engineering approaches to climate risks? When we think about information in particular, in what type of knowledge we can produce just by understanding how the Earth system is evolving, how the climate is affecting weather extremes, in how can we improve some of the forecasts and warnings. So this is the space where a lot of NCAR scientists are working, and particularly looking how this information might interact with other elements of vulnerability and knowledge about the hazard. And also, as I mentioned, there's also, some of the intervention and coping and response factors could be related to programs, assistance, education, and others. But kind of the takeaway message here is that when we think about the risk is evolving. It has multiple dimensions. And vulnerability is also not static. It's contextual, it is also situational, and it's shaped by many local factors and also external factors. And so that's where we have to look at the system together by combining knowledge about physical system, the social system, and consider things like agency, decisions, and behaviors, because those can play a really big role in the outcome of a particular hazardous event, and where we can see how the disaster aspects play out. So how do we do this type of work? So in order for us to understand and reduce the risks from weather and climate, so typically the work that I've been doing and my colleagues are doing, we try to adopt an interdisciplinary approach, or sometimes even convergent approach, that really starts at identifying societally relevant problem. So what kind of problems that we're trying to solve can drive what types of scales we might want to consider, what kind of methods we want to adopt, and what disciplines need to come together to better understand and reduce some of those aspects of weather and climate extremes and weather disasters. This integration of discipline also has to be intentional. And by intentional, I mean that we really have to think about this problem together to sometimes create new concepts, new ideas. It's not just exchange of data between different disciplines. It's truly interdisciplinary work where we think about, how do we bring atmospheric, social, behavioral, maybe data science, health science, and building sciences together that can help us understand what elements of exposure, hazard, vulnerability interact to produce risk, and where can we intervene with either with some new information for warnings, for risk communication, or for some of the long-term strategies, for example, that would be related to structural mitigation or potentially migration or relocation. It is also important that not only that we work with community and stakeholders, so we can better inform the hazard preparedness and response in climate adaptation in the long term. So we cannot do it in isolation. It's extremely important to learn from the communities about what problems they're facing and what information would be useful, and what kind of tools or information not only useful but usable in terms of that it can really affect decisions and make sense to people when they receive that information. And so when we think about improving risk communication, we have to think about diverse audiences, again, going back to all these different elements of vulnerability, and also think about different formats and messages in terms of delivery of this information, provision of information. So if you think about information as one of the intervening factors in reducing future impacts of weather disasters. And if you put it in the context of one of the coastal hazard, which is a storm surge, so we really kind of have to unpack, how this risk communication and warning, how does it interact with individual capacities, with sensitivities, with exposure, and especially when we think about uncertain information. Storm surge, in like many other weather disasters, sometimes difficult to predict, and we sort of have to realize that we're dealing with uncertain information. And so if we want to know what is the probability of occurrence, where the disaster may take place, how it's going to impact the communities. So we need to think about all of those different things. And we also have to realize that information is necessary, but of course not sufficient for reducing risk. But exploring the informational aspects of vulnerability can help us to identify the points of intervention for risk reduction. So if we want to focus on storm surge as one of the weather extremes, climatic hazards, it's one of the hazards that affect a lot of populations in the US. along the East Coast, the Gulf of Mexico. And if you look at the literature, it shows that storm surge accounts for nearly 50% of hurricane-related human mortality in the US. So it is one of those very significant coastal threats that affect many communities, and it can potentially increase with future climate change and sea level rise. It is also, as I mentioned, sometimes difficult to forecast specifically, what areas may receive how much flooding. And so there's an inherent uncertainty in the storm surge forecasting. Predictability of storm surge at specific locations can be challenging and could be limited. Of course, it depends on the storm characteristics, and we see a lot of advancement in the forecasting abilities. So this is an image of forecast for Hurricane Irma, for example, which was really close to its actual track. But the fact that sometimes the forecast and accuracy of forecast is limited to as little as 12 to 24 hours before the landfall, but people have to make their decisions about evacuations, about protective actions before that, 48, 72 hours, 48 hours. And so how do we combine the uncertain forecast information with effective risk communication, considering some of the elements of vulnerability? So this type of work we explored in a recent project that I worked with my colleagues at NCAR, which was funded by the National Science Foundation through the Hazard Seas grant. And the project called Communicating Hazard Information in the Modern Environment. And so the goal of this project was to better understand the dynamic information system and to improve risk communication and response. And there's a paper that was published in BAMS. So if anybody interested, I would be happy to share that paper that talks about different ways to look at information and how can we improve predictability of storm surge from the physical science side. We analyze the social media and how the social media, in particular Twitter, represents the exchange information, provision of information to broader public. We have an agent-based model also that looked at kind of the provision and exchange of information between different actors in the hurricane scenario. We also worked with vulnerable communities. So that was one of the aspects of the project where we specifically wanted to understand how some of the underserved communities receive information, make sense of it, and what sort of capacity exists in those communities to make decisions based on that information. And there's also work on the visual aspect of risk communication. So let's take a look at some of those findings, so some of the work through that project. So first of all, when we look at the weather phenomena, at the weather disasters, so it's a pretty short time scale that we have to consider. So here we're looking at kind of this abstraction of the hurricane forecast. So the time before the landfall, by the time we start seeing forecasts and to the time of the landfall, somewhere between 5 days to 12 hours. And so a few days before the landfall, there is a lot of uncertainty about where the hurricane may make a landfall, how much storm surge it may be. And those little nodes and lines represent different people who produce information and share information. And as closer we get to the landfall, the more people are starting looking at information, share information with each other, and making decisions. And so as we get closer and closer to the landfall, we start getting more certainty about the location and potential impacts of the storm. And also people have different sources of information that they have to consider, from official sources to their neighbors and family and social media. And so there is a lot of dynamic information exchange going on in that space. And so we recognize, so as hurricane approaches and arrives, the forecasts and the warnings have to interact with the societal information flow and decisions as people make. One of the questions we wanted to ask in this project is how does communication of risk either alleviate or exacerbate societal vulnerability to hurricanes by influencing the information that people receive, their perceptions of approaching hurricane risk, and their behavioral responses. So this type of work included, as I mentioned, some of the social science methods, and I wanted to talk today about two case studies. One where we conducted focus groups in New York City after Superstorm Sandy. And just as a reminder, Sandy made landfall in 2012 in late October in New York. And we also did a focus group with communities affected by Hurricane Matthew, which made landfall on October 8th in 2016 in South Carolina. And I should also mention that even though in the recent years we have seen a significant amount of hurricanes and tropical storms in the Atlantic and the Gulf of Mexico, but in this time period there was a relative sort of a pause in hurricane activities. And so Hurricane Matthew was one of the major hurricanes in the 2016 Atlantic hurricane season. So in New York, we wanted to, as I mentioned, talk to communities that may or may not be underserved. And we also wanted to see how some of those vulnerabilities and information sharing would affect their capacity to respond and make decisions. So we selected focus groups based on a number of factors. The first one was looking at social vulnerability index, as shown in this map. And so these are the locations of the focus groups. We wanted to look at different degrees of vulnerability. Some of them had high vulnerability, some medium vulnerability, but all of them had some degree of social vulnerability. We also wanted to talk to communities that were significantly affected by Superstorm Sandy. They were located in evacuation zones. And also those communities were in the areas that did not receive a lot of Twitter activities. So in a way, we were exploring the digital divide and wanted to look at some of the population that may not be connected to the social media as maybe some other communities have. And so as you see, there's not as much Twitter activity in those places that took place during the forecast and landing and shortly after landing of the Hurricane Sandy. So we conducted 8 focus groups in October of 2015, and that was about 3 years after the hurricane made landfall. But even the 3 years after the event, most of the people we talked to, they were still experiencing a lot of trauma, and definitely that experience was so significant that they were the memories of that event were still quite fresh. So we had 2 focus groups on Coney Island, 2 in the Red Hook in Brooklyn. We had 2 focus groups in Far Rockaway, and 2 on Staten Island, 1 in Midland Beach and 1 in Elm Park. And we wanted to talk to a diverse group of people. Some of them included long-term residents, especially people who have lived on Staten Island for a long time and have experienced flooding, frequent flooding, nuisance flooding over the years. We also wanted to talk to people of different cultural backgrounds, Spanish speakers, Russian speakers, some of the newer immigrants, and some of them were undocumented immigrants, to understand how their experiences and culture and ability to use information may affect their decisions. So we had a number of questions, and I know some of you who have looked at this paper already know some of the methods we used and the key findings, but just to reiterate, we really wanted to explore themes related to hurricane risk communication and vulnerability. In particular, some of the questions related to the timing, sources of information, content of information, participants' prior experience and perception of risk, especially some of the experiences related to Hurricane Irene that happened before Hurricane Sandy, and how that may have affected people's decisions. The role of social network, as I mentioned, is really important. So we wanted to know what people our participants interacted with and how these people help them to make decisions, especially if the participants themselves may not have been connected to social media, but maybe their relatives or friends have. What kind of decisions they took and what sort of the outcomes they experienced in their general reflections. So I'm just going to skip through some of the kind of broader themes to some of the key lessons learned for the sake of time. So some of the things that we found is that the access to and understanding of information played a role in mitigating vulnerability. However, some of those factors, while they were important, they were also mediated by other things. Interpretation of risk information was definitely affected by participants' experience, how they interpreted uncertainty. There was an element of surprise because even people may have experienced nuisance flooding or had experience with Hurricane Irene. They were so much surprised that they were just really, hard to understand this information, to trust in the information, and really, how to make the decisions in that situation. Because we talked to people from diverse backgrounds, Russian-speaking, Spanish-speaking, especially some of the Spanish-speaking people included people from Puerto Rico and also from Mexico, including undocumented immigrants. And so there were definitely cultural attitudes and language barriers that prevented people from evacuating or making protective decisions. This Russian-speaking population in particular, it was interesting to learn that even though people were provided an opportunity to evacuate, but because there were no Russian translators on the buses that were provided to some of the senior residents who live on a Coney Island, people were just really frightened to get on a bus without knowing, where they're going to go, what's going to wait them there. And so people actually changed their mind last minute and chose not to evacuate due to some of the cultural and language related issues. Social networks, including family, and as well as housing situations also played a big role. So for example, people who lived in public housing, they had a much larger capacity, for example, that people who lived in private housing in the same neighborhood, because they had staff or local authorities informing them, providing brochures, providing information, making sure that they're aware of the resources that they have, while people who may have lived in private housing with the same level of income did not receive this information and were surprised to see water rising on their streets. As I mentioned, there was some information gap that was caused by the digital divide, and it was important to use multiple means of communication, because just having a cell phone or didn't mean that people had access to internet or were able to interpret information. Some of the more senior people still used radio. Spanish-speaking people used Spanish-speaking TV channels, and there were some conflicting information that they were receiving. And overall, what we learned that there was definitely some challenges in communicating to those diverse audiences, and challenges in producing messages that could be simple, that could be reliable and accessible to the broad audiences. And some of the participants really spoke about the need to being able to visualize the risk either because of the lack of experience or lack of trust, or not be able to understand some of the technical aspects related to forecast uncertainty. They talked about that would be really helpful to be able to visualize the risk in a way that could span across different languages and help people see it better. And so that led to the next part of the project that relates to the visual risk communication. So there's a lot of work already that has been done in that space, and there's a lot of literature that talks about how visualizations in general play a central yet complex role in communicating information and building trust. Some of those visualizations could be very simple, from drawings that how we can illustrate what storm surge mean and what may be affected, to some of the really innovative, state-of-the-art virtual reality, augmented reality visualizations, as I'm sure all of you, or most of you, have seen in the last few years, showing what the storm surge may look like. However, we still don't know what aspects of visualization, particularly geovisualization, may increase individuals' understanding of storm surge information and the likelihood of taking protective action. And so we expanded this work by designing several risk communication prototypes. And the concept that we wanted to represent in those visuals were looking at the dimensionality, two-dimensional, three-dimensional visualization, looking at abstraction and realism in those images, the role of scale, how do you present information at regional, urban, suburban scale, how can we better present flood levels or the speed of storm surge, represent uncertainty, and also include any other additional information that might help people understand their risk and interpret information better. And as I mentioned, we used the context for this work was Hurricane Matthew, which was the most powerful storm of the 2016 Atlantic hurricane season and affected many communities in Georgia and South Carolina. So before Hurricane Matthew made the landfall, these were the types of images that were disseminated in the media. And you could see there's so many different ways, either official sources or local broadcast meteorologists or other media sources can use basically the same information but presented in multiple different ways. You know, people talk about reasonable worst case storm surge. They present information and probabilities. They talk about some of the qualitative classes, elevated, moderate, high, extreme. They show the numbers of water levels. And this is just to say that when people are looking for information in trying to make decisions about protective actions, evacuating, it sometimes could be a lot to interpret and understand because there's no consistency in how information is presented, and you know some information works for people, but others might be a little bit complex. And so that's kind of what we wanted to explore in this project. And so we conducted 7 focus groups in June 2017 with communities affected by Hurricane Matthew, and 2 were in Beaufort, South Carolina, 3 were in Brunswick, Georgia, and 2 were in Savannah, Georgia. And so just as we worked in New York, as I should have mentioned, in New York, we worked with local partners who helped us to recruit participants for our focus groups. It was the same kind of process in Georgia and South Carolina. We worked with local partners to recruit the participants for this project. So these particular focus groups were designed to really have a better understanding how people make sense of information, what kind of meaning they derive from visual images and from maps, how do they make decisions based on the information presented to them. So we presented to the participants a scenario. We said there's going to be a hypothetical storm affecting your area, supposed to make a landfall 48 hours. And we showed them a sequence of maps with different scales. As you can see here, we printed those big, large scale maps and showed them in a particular sequence. And we were just observing how people were making meaning of this, what sort of things were confusing, what was clear, and how some of that information presented helped them make decisions. So I'm going to go through some of them with a few quotes from the participants. So the very first one was the map of the area that said, okay, it's going to be potential storm surge flooding. That's going to be at noon Wednesday, June 7th. That was a hypothetical scenario. And it's going to be flooding anywhere between 1 to 9 feet above ground. And so even though it seems like this is not a very informative image or map, from the predictability of the storm surge, that's probably one of the more accurate maps we can give, just because again, the 48 hours in advance, it's really hard to tell how much flooding is going to be in this area and where exactly it's going to be affected. So there is this inherent uncertainty. We also showed people the same map, but the timing of the event was presented differently. It's exact same information, and this type of information is frequently communicated through the official sources and broadcast and media, but it's presented differently because again, there's uncertainty in the timing of the event. And so people definitely could understand that it's the speed, the temporal uncertainty. And they were saying, yes, it's pretty hard to nail down a storm surge for any given single time. So the temporal uncertainty was pretty clear. But when we showed them those regional maps, people were not quite ready to make decisions. They were saying, well, those first two maps you showed, that wouldn't do me much good. That's, I can't pinpoint my house. I can't pinpoint the roads that lead out of Greene County. I want to be able to see that stuff. And so this just shows how people are looking for something that they can relate to, they can identify their home, and this type of information was hard to interpret. Although scientifically, it's probably one of the more accurate way of depicting uncertainty. The second set of maps, we created a legend between 1 to 3 feet, 3 to 6 feet, and 6 to 9 feet, giving a little bit more detail about the flood depth, and also gave them some indication of what that flooding may look like. Because, when we spoke with people in New York, they had really hard time understanding. Some participants had hard time understanding what does it mean, in terms of impacts. And so here we enhance these visualizations with the images of the homes in hope to aid the risk interpretation and decision making. And in general, that was pretty well received. Somebody said, yes, that's very helpful. If I was in a pink area, I would try to mitigate, get freezers elevated, get any machinery in the garage elevated, The mid pink, it's pretty, the red, forget about it. So people start kind of not just understanding what it can do, but also what kind of actions they may need to take. So the urban scale, so this is an image of Savannah as an example. That's where we start showing some of the potential highways and roads that may be affected. Again, there's the same classification of flooding. And that's where people kind of starting to really zoom in, and they start, kind of looking for what their neighborhood may look like. And somebody said, I could say that by far the most helpful and above ground makes sense to me on this one because I know where my ground is on that map. And again, that's something that people have to interpret, because when we give information about flooding, we say flooding above ground. And so that way they can say, okay, if I live in this neighborhood, I know exactly elevation of my house. I know what this can mean to me. So again, that kind of personalization and understanding of their local environment and their surroundings was really helpful for them, for the participants, to make sense of their risks. When they start going into suburban scale, I think that's also was really helpful for the participants, because we can also identify which roads could be flooded, maybe put some landmarks that someone can identify with, whether it's parks or schools or hospitals. And that was also helpful. Somebody said, everyone is not weather educated. They want to look at it from the distance and go, okay, it's going to affect me. So again, just a really hard time understanding uncertainty, but something that's simple, clear, with familiar landmarks was helpful to people. But then also participants were really kind of putting this information in the perspective of their everyday lives, about their capacity to respond, about their vulnerabilities. And so this quote, somebody in Savannah said, as well, not even nowhere, because you're saying by Wednesday, the storm will happen by Wednesday. Normally the people working 9 to 5, like we do, and then you're saying, I'm tired, I'm hungry, I just want to go to sleep. I got one more day. then it's going to hit you. Then you're going to wake up and be like, well, I should have listened. And so again, this is just really helpful information for us to understand that even though people, they receive this information, that might interpret this information in a way that help them understand what they need to do, but they're not always ready to make that decision because of all the other constraints that happen in their lives. Uncertainty played a big role in this as well, because we wanted to talk about uncertainty in the forecast. All of the information that we presented here was actually information from the NOAA Storm Surge Advisory that was officially disseminated for that particular event. In that forecast had 10% probability of this particular disaster or flooding occurring in the area. And so we looked at a couple of different scenarios, looking at 10% probability, 30% probability, and there would be less flooding and a 30% probability, but more flooding in the 10%. And so that's produced a lot of different and interesting discussions, and people were really kind of separated on these issues. Some people said, if you have a family and kids, it doesn't matter. I'm just going to go. It doesn't matter what the forecast is and how bad this is. But other people were saying, if I have 30% chance or better of not leaving my home, then I'm going to take my chances. So it's really interesting. Again, the situational vulnerability plays a role in what people can do with this information, even if they understand it. So unfortunately, I had an animation here, and unfortunately I had some technical issues today, so I can't run it, but I would be happy to share separately. But one other aspects of this research was to produce a realistic 3D animation that shows how quickly the water moves inland, and how high the water level can be in a short amount of time. And again, this was informed by our conversations with people in New York, because a lot of people just couldn't believe their eyes when they saw the roofs of the cars floating outside of their homes. And even some people were looking at it of thinking those looked like giant turtles or something. They just couldn't quite comprehend, the effect of the storm. Some people went on a beach taking photos and then were completely taken by surprise again, because they couldn't get to their home soon enough because the water moved in very quickly. And so showing this animation again, like in representing the speed of the storm and how quickly it will help participants to interpret the risk. And somebody said that a combination of maps and videos might even have a big effect, because you can look at the map all day, but even though you don't know where the street is, it's definitely telling you how fast it's going to happen. So some of the lessons learned from this work is that when people looked at some of those images and what kind of information they were really paying attention to, it became pretty evident that the sense of place and the representation of forecast uncertainty played a role in how they personalize or how they interpreted the risk. Same as in New York, prior experience, social and environmental cues, what's happening outside, what are my neighbors doing, what are my children doing, all of that played a role. Household resources also was a big role. Even some people received information, but they had no means to evacuate, or their jobs required them to stay. And so, but again, some of them were related to place attachment, because people who really knew their environment really well, they chose to live in this environment, they know their risk, and they were willing to accept it. And showing the information at multiple scale was helpful. Realistic visualizations were helpful, whether that was images of the flooded homes or the animations. And now, kind of thinking about, some of the broader themes and lessons learned. So we developing some of the recommendations for the Hurricane Center, and now collaborators at NOAA, how to potentially improve some of the visualizations for future forecasts and risk communication. And sense of place, as I mentioned, was really a big theme that came out of this work. So we received another grant just recently where we're specifically looking at integrating sense of place concept into the storm surge geovisualizations, because some of the issues related to sense of place, whether it's place identity or place dependence or place attachment, may really play a role in how people understand and respond to the hazards. So going back to this diagram that I showed before, I hope I was able to illustrate how some of the uncertainty related to the hazard, how do we, what can we forecast in terms of intensity, duration, spatial extent, when the event happens, what can it produce, how that interacts with the information, risk communication, and forecasts, and what other interactions we can see between the capacity and also the sensitivity that some of the coastal communities may have. And I think it's also interesting to look at the sense of place, because I feel like the sense of place research can also give us some better understanding about exposure as well, why some people choose to live in the places they live, and again, what kind of information could be helpful as intervention points to reduce future impacts from hazardous events. It's important to understand this information and really to think about some of those novel approaches. How can we understand and reduce future risks? Because if you look at the climate change again, and their impact on the storms, just even the recent trajectory shows that some of the Atlantic hurricanes are getting stronger. The storms, coupled with sea level rise, more and more communities will be affected by coastal flooding. And so this issue is not going away, it's only going to be more prominent. And so by combining expertise from physical sciences, atmospheric sciences, and social sciences, we could start thinking about not only the long-term risk that would be associated with climate change development, sea level rise, but also some of the short-term risks and responses that potentially could be mitigated through better risk communication and understanding vulnerability. Okay, so some of the takeaway messages. So as I mentioned, we live in a society that is changing very rapidly. Climate and society are co-evolving in a manner that can place more people at risk from weather-related hazards. So we do need to understand those kind of complex relationship between weather, climate, and society, and those include vulnerabilities, ways to better communicate risk and understand what information is needed and who is going to be using it and how. I think there's going to be only growing need for that kind of information in the future. And hazardous weather information provision and comprehension is a critical social structure at play in disaster contexts. And so by examining some of the points of intervention in the information system, we can improve access to and understanding of hazard information that could hopefully can lead to improved preparedness and response. And as far as geovisualizations, I think this is really an exciting area to work in, because there's a lot of advancements that's happening in geovisualization. They have potential to improve risk communication, but we also have to make sure that the way they're designed are actually informed either by theory or empirical research in order to be effective for diverse audiences. So that's my last slide. I just wanted to thank you for coming, also acknowledge my collaborators. Many of them are at NCAR, Heather Lazarus, Jennifer Bonner, Rebecca Moore, Julie Demuth, also Alexa Dietrich, who is a professor at Wagner College on Staten Island and also with the Social Research Council. Our collaborators from University of Georgia, Utah State University, University of North Carolina in Asheville. And again, some of the work that I presented today has been funded by the National Science Foundation. And I have my email here. And again, sorry about the animations not working, but I can just send it to Kevin. And if anybody's interested, I can share those. So thank you.
All right. Well, thank you, Olga. So virtual applause. So yeah, now we have time for some questions. So please, I encourage everybody that has a question to use the raise hand feature. I will go through that as questions pop up. And so the first question we already have is from Steve Schwartz. So Steve, you want to unmute and ask? Yep.
Yeah, hi, Olga. Thanks for the talk. As you were giving your talk, I couldn't help but thinking about Texas last week and sort of wondering almost a disconnect between what you were focusing on, which is sort of individuals and their ability to make decisions for themselves versus decision makers, utility operators, utility managers, regulators, all of whom play an important role. And the tough decision on the part of the individual who doesn't have information of major nonlinearities. The power is going to go out. That's a major nonlinearity. And that means that something that relies on electric power, my ventilation system for somebody who's impaired breathing function is going to go out. Those are big kinds of nonlinearities. And so I don't see a connection between how somebody facing that Texas ice storm could make individual decisions. It seems to be much more societal.
I think you're absolutely right. And so if you remember when I showed that diagram, kind of looking at some of their larger social processes and constructs, right? So we have, if you think about the individuals, and their agency, right? So they are in the context of their community, in what the community's agencies are. And then we have to then put it in the context of the broader societal constructs and processes, right? So I didn't talk about this in this particular presentation, but another work that we do, when we look at vulnerable population, we have to take into account some of the systemic inequalities or health disparities or the governance, right? So, and I think the aspect of governance really was on the forefront of this Texas disaster, because if you think about how the natural resources are regulated, what is the role of government versus private sector, and whether the communities and individuals have a role in that, right? So I think there is a lot of those kind of macro level factors that play a really critical role. And just I think you were absolutely right, because that just highlighted not only individual decisions, but some of their larger kind of long-term, the history and long-term processes that led to that disaster. So yeah.
I think there's a real failure on the part of regulatory bodies and governmental bodies that then resulted in all the individual tragedies, one after another, that were a consequence of all this. So I think, in some sense, almost you tended to be focusing on individuals with these interviews and whatnot. But I think it's much more something for government to be paying attention to.
Mm-hmm.
Great. So I think, Sarah, you said you have to leave, so you can ask the question next, and then we'll go to Alyssa.
Thank you. Thanks so much, Olga. As always, learned a ton from your talk. I do have a question, which is also a practical problem that I do have with another research group right now. You were showing maps, and there were different granularities and levels of refinement where you were showing levels of hazard risk. And you had these very nice quotations from people saying that because they could see that their parcel, their property is going to be at XYZ level of risk, pink or red or whatever color, this would change their decision. Now, in another project, we were debating exactly doing that for community engagement, for long-term resiliency decision making, and showing these kinds of maps to property owners, to whoever that would come to those workshops. And interestingly, there were concerns about, we don't want to show as refined levels of those maps that shows the properties that would get flooded in these many years, or the frequency of flooding, or whatever different types of risks. Because then the local stakeholders who are in the room in those workshops, the urban planners, the city manager, the people who make decisions, And they are going to be concerned about local politics and tensions that would be caused by showing these realistic but refined levels of risk. I'm sure you have also thought about these dilemmas, so I'm interested to hear your thoughts on that.
Yeah, thanks, Sarah. I think that's a really, I think, an important question, because I think you're absolutely right. Because once you actually put a line on a map, right, it becomes you either in the area or you're out of the area, right? And I think especially when we deal with information that is highly uncertain, right? So I think we have to make those decisions, because that's part of the work that we're doing, is really trying to find that balance between how to inform people that they can make decisions without giving them sort of this false sense of certainty, right? And if you remember, like one of the first maps that I showed, that was like the whole coast was pink, right? So that's probably the most accurate information that should have been given, because we don't know. We don't know. It could be, you know, anywhere. But because I think people are looking for, they feel like when they're more informed, right? So then they can make better decisions. And I didn't put a quote from a participants, but they were saying, you know, when I have information, then I'm not afraid to leave, because I have that information in my pocket and I can make those decisions. So I think I don't have a good answer for you right now, because I feel like it is an area of research that, you know, we can do more work in, but I think we just have to really find that way to show as more detail as we can, while informing people that it's, you know, there's uncertainty related to that information. And I think especially like with the forecast, you know, because, you know, the closer you get to an event, the more and more certainty we have. And so there's definitely more opportunity to show more detailed information in a forecast kind of, you know, scenario. When you think about climate in the long-term resilience, that becomes more difficult, right? Because that's where we just don't know. And, you know, but showing scenarios, you know, showing options, I think that's what, you know, we've done in the past, you know, saying, you know, this is your worst case scenario, this is the best case scenario, and it could be anywhere in between. Or it could be even a surprise of that exceeds worst case scenario. And so that's kind of that balance.
All right, so next up, I think, is Alyssa.
Hi, yeah, thank you for the presentation. It was super interesting. My question, I guess, maybe relates to Sarah's question a little bit. I understand why people would want very localized information, such as that really small scale storm surge map that you showed. But I would fear that providing such like small scale predictions would increase the risk of like a false alarm. Because our, you know, our forecast models aren't down to that level of detail. So I was just wondering, yeah, your comments on the risk of false alarm, and maybe if any of the people you talked to mentioned like Hurricane Irene being like a false alarm, like maybe it wasn't as bad as they thought, so then they thought Sandy wouldn't be as bad either.
Yeah, that's a really good question. And we definitely heard from a lot of participants about Hurricane Irene and how that affected their decisions to, you know, take protective actions during Sandy. You know, we also did focus groups after Hurricane Harvey in Texas, right? And it was kind of a similar situation where nobody could believe the models, because they're like, there is no way there's going to be 50 inches of rain. There's just not even, you know, it's not possible. And so people just could not comprehend what that would look like, right? And again, I think sort of our role in thinking about risk communication, I think we have to stay true to the forecast. Absolutely, right? We have to stay true to the forecast. We have to represent uncertainty. But I think part of this work in connecting risk communication to diverse audiences and how people personalize risk, how they interpret it, and what sort of messaging could be helpful, is to show them what that could look like, right? Because if they didn't have experience with a really bad storm, if they, you know, because a lot of people were so surprised, they were just surprised. Even there, they heard the forecast. And that's across all the storms we hear again and again. The forecast was, you know, there, provided, it was even pretty accurate. But then people like, I was so surprised to see water in my house, right? And so I think just maybe illustrating it in a way that shows them what could it look like. I think that's where that kind of interesting research area is in terms of combining predictability and uncertainty with some of the more effective communication strategies, right? Because we definitely don't want misinform anybody and then lead to, mistrust in the future. But if we can say, okay, this is what it is, and that's what it would look like in your neighborhood if it happens. So that's my take on it.
Thank you. Yeah.
All right, next up is Kamazima.
Thank you, Kevin. Thank you, Olga, for such a wonderful talk. I'm just gonna borrow again from Sarah's question. When I heard her question, I kind of heard two different scales. She was kind of referring to more long-term, maybe on a climatic scale. And my fear is whether when you give such a detail and with such uncertainty we have in projections, that might translate into money because the insurance companies are going to be there and thinking, Kamazima's house is no good, so I'm going to have to start paying a much higher insurance, and people might not even want to participate in that case. I don't know if that's the part I took from Sarah's question, and I don't know what's your reaction to it.
Yeah, I think that's really interesting because I should have showed this one quote where somebody was talking about seeing information, highly uncertain information, right? So like 10% probability. And somebody said, like, what do you expect me to make financial decisions based on that? Do you expect me to make my personal decisions based on that, right? So I think people interact with uncertain information, especially in a weather context, right? So I think the climate is a little bit different, right? Because it's, there's a projections, right, for the future. In the weather, hazardous weather context is a little bit different because it's such a short time scale, and we have to warn people so they can take protective actions. In terms of climate scales, I think it's a little bit different because we have to, again, think about all the different uncertainties that go into the climate projections, not just uncertainties in a physical system, but also uncertainties in a social system, right? Like, who could have predicted pandemic? I mean, some people have, but right now we just, looking at this and thinking, okay, we have all sorts of I bet a lot of demographers and people who do population projections now revising a lot of those scenarios in terms of, if people are going to be moving, migrating, or what the economy is going to do after this type of disruptive event. And so I think there's a lot of uncertainty there. And again, I think if we can better communicate uncertainty, right? So I think, there's improvements in understanding of Earth system in general, right? And so people are working on this, and improvements in understanding of social structures and social systems as part of the Earth system. But we can't provide a forecast, right, for that kind of scale. We only can provide projections and scenarios. And even though I think what your question, I think Sarah questions are really good ones, because people want precise information, but the precise information may not be accurate, right? And so how do we give them that level of detail that they can inform what they're doing, but yet be able to communicate uncertainty associated with that information? And I don't have all the answers. That's something me and my group are working on. So, but if anybody has great ideas, I'm happy to collaborate.
Right. Thank you.
Awesome. Okay. Well, we're a little over time, and I don't want to keep people from other Zoom meetings, but I want to thank you again, Olga, for joining us today and for this very interesting discussion that we've had and the talk. So thank you. And we'll see the rest of everybody else next week. So
Thank you so much for inviting me, and
Yes. Thank you.
it was great to see you.
yeah.
Bye.
Goodbye, everyone.
Bye.